Hi and welcome to another video from the team of 5G. This is Abubakar, an early stage researcher from the team of 5G, which is an European Horizon 2020 MSCA Innovative Training Networks with agreement number 813391. In today's video, I'm going to talk about an advanced 5G IoT access point. Without further delay, let's get into the content of this video. I will first start with an introduction about IoT and 5G, followed by IoT Connectivity Technologies and the access point structure, followed by scenario of using this access point and the advantages of using such access point, and finally the challenges that can face this access point. The Internet of Things or IoT has been there for decades. However, in the recent years, it has gained a very high attention due to its impact in everyone's life. We are all connected using mobile phones, smartwatches, tablets, computers, and other devices. There are a lot of applications and systems for the Internet of Things, such as smart cities, smart homes, smart agriculture, and new application and systems are introduced every day. All these applications and systems involve devices that are connected to the internet, which means that the number of connected devices will keep on increasing exponentially in the coming years. Therefore, we need a technology that is able to handle such huge amount of the increased data and connected devices. 5G seems to be the solution for this problem. 5G is the fifth generation mobile network system. It's considered as 10 times faster than the current LTE network. It also has greater network reliability, high speed connectivity, very low latency, greater coverage. It also can coexist with different technologies. All these advantages that 5G has can bring up a very powerful IoT system. As we all know that an IoT system is tied to its performance, and all these advantages that 5G has can help to achieve this goal. Now we are going to see the different type of IoT connectivity technologies. IoT connectivity technologies has two types, long range and short range. The long range is classified into cellular network and low power wide area network. The cellular network include all the generation of mobile network from the first generation to the fifth generation, and the low power wide area network consists of the licensed and the unlicensed network. On the other hand, short range technology has a lot of technology in it, such as Bluetooth, Wi-Fi, and Zigbee. We'll go in details in the coming section for these technologies. There are so many technologies that are used for short-range communication. Some of these technologies are Bluetooth, Wi-Fi, and Zigbee. Bluetooth is a very popular wireless technology that is primarily used for communication between portable devices that are distributed in a very small area of around 10 meters coverage. The transmission data rate between Bluetooth devices can go up to 3 megabytes per second. On the other side, Wi-Fi technology is commonly used for wireless local area networks. It can connect many devices together, and the coverage area of wireless technologies is about 50 meters, while the transmission data rate of wireless technologies can go up to 300 megabytes per second. On the other hand, Zigbee is another short-range wireless technology that is used for wireless personal area networks. It has been widely used for various IoT applications such as home automation. It is also a low power technology, and it's operated in the unlicensed band. The transmission coverage area of Zigbee is around few meters up to 100 meters, and the transmission data rate can go up to 250 kilobytes per second. Besides that, we have the long range technologies, which has two types of networks, as I mentioned earlier, the cellular network and low power wide area network. The cellular network includes all the mobile network system generation from the first generation to the current generation, which is the 5G. Each of these systems has different types of technologies, bandwidth, frequencies, as well as applications. On the other side, we have the low power wide area networks that can be built on top of two types of bands, the licensed band and the unlicensed band. The licensed band consists of the LTE-M and the NB-IoT. The LTE-M is a simplified version of LTE that is mainly designed to support low cost and low power consumption devices that can be used for IoT applications. It can cover up to few kilometers and the data rate can go up to 1 megabytes per second. NB-IoT, on the other hand, is also built on the existing LTE functionality but with a single narrow band of around 200 kHz. It can cover wide area compared to the LTE-M, and it has a data rate up to 250 kilobytes per second. The unlicensed bands has many technologies. Among these technologies, we have LoRa technology and SigFox technology. LoRa stands for Long Range Technology. It has been introduced by Semtech Corporation in 2012, and it can cover up to 20 kilometers, and the data rate can go up to 50 kilobytes per second. On the other hand, SigFox uses an ultra-narrowband technology with only 100 Hz bandwidth for very short payload transmission and it can cover up to 50 kilometers, and the data rate can go up to 100 bits per second. After we have introduced the different types of IoT connectivity technologies, we are now going to present the structure of the access point. The access point contains of different types of layers, such as the application layer, data management layer, operating system layer, and hardware layers. Each of these layers has different types of tasks to handle. For example, the hardware layer is responsible to gather and integrate the different types of modules and interfaces that belong to different types of technology that we have seen earlier. Once this integration is done, the operating system layer comes into the picture, and it's responsible for configuration of the different modules in order to prepare the data to forward it into the data management layer. Once the data is forwarded into the data management layer, the data is ready to be used by the application layer. This is how these different types of layer works together. Next, we are going to see a scenario how we can use such access point in real time. Here is a scenario that we can use the access point. In this scenario, we have two types of access point. One is this 5G access point, which is an outdoor access point, and the other access point is an indoor access point, which is located in a rural area network. We'll first start with the indoor access point, which is connected to different types of devices that uses different types of technology, such as Bluetooth and Wi-Fi. This indoor access point will collect data from these devices and forward it into the 5G access point using a low power wide area network technologies such as LoRa. In this scenario, we have used LoRa, and the 5G access point, on the other hand, will forward the data that has been received from this access point into the cloud, And once we have the data in the cloud, our application can make use of it either from a mobile application or from a laptop. This was a simple scenario of the usage of the access point. In this section, we are going to see some of the advantages that we can get by using such access point in our IoT application. Among these advantages is achieving the IoT vision, which is anywhere, anytime, anything. Another advantage is the integration of different types of technologies in one device. This can help in also reducing the cost. In order to achieve such powerful access point, we have to go through so many challenges. Some of these challenges are performance, as we mentioned earlier that any IoT system is tied into its performance. Another challenge is the scalability of the device. We also have an important part which is present a very high challenge, which is security, as we are connecting different types of devices that use different technologies. We have to take care that the data that has been forwarded by these devices has been forwarded in a secure manner. And finally, we have to find a solution by optimizing hardware and software together. This was all about this video. I hope to see you again in another video. And thank you so much for watching.